Excellent.
Welcome to the Metasploit team demo meeting. It's been a busy last few weeks. We've had many modules and also did the final Metasploit Town Hall installment at the final DerbyCon.
Hey.
That was exciting. Whew. Let's hop in. We've got some new modules, lots of new modules actually.
Heck yeah, we do.
Yeah, we do. Contributor Petrib added 4, count them, 4 new modules for Cisco targets. The first module changed two of these modules target vulnerable versions 6.6 and 6.7 of Cisco's UCS Director software. The first module changed 2 Authenticated as an administrator and 2 inject commands via the password change form, which allows unvalidated inputs leading to unauthenticated remote code execution as root. The second module takes advantage of known default user credentials to SSH in the target and get a session as the SCP user on the system. While this module was tested against UCS Director, the Cisco Security Advisory, it mentions that some versions of UCS Director Express and also IMC Supervisor are also vulnerable. We've not tested against those though. The other two modules from Pedrib target vulnerable versions of Cisco Data Center Network Manager. The first module chains up to 3 exploits. So 1, bypass authentication, 2, download information to locate the appropriate upload directory, and 3, upload a web archive file to Apache Tomcat to gain remote code execution on the target. Due to incorrect permission settings, this module utilizes the file upload servlet endpoint to upload a payload, which it then executes as root. The second module allows data exfiltration through the file download via the download servlet endpoint and some incorrect permission settings. Vulnerable versions 10.4, 11.0, and 11.1 were tested, with only 11.0 requiring authentication. The other 2 tested versions do not require authentication thanks to the module automatically chaining an exploit for an authentication bypass. And I believe those information about those versions goes for that first module there, the unauthenticated remote code execution against the data center network manager as well. And some more new modules. Contributor ktsuss provided a module targeting vulnerable wireless presentation devices made by AwindInc, which was acquired by Barco earlier this year. Vulnerable devices which have an SNMP read-write community value can be exploited via the ftpfw.sh script that they contain to obtain command injection via system. Additionally, some OEM devices manufactured by other companies such as Crestron's Air Media and Newline's TrueCast devices have been found to be similarly vulnerable. We touched on this backdoor Webmin module in our last demo meeting and made it into the release since then. Last year, backdoor was added to the Webmin system administration software hosted on SourceForge, allowing attackers arbitrary code execution as root. After this backdoor recently came to light, our own William Vu created a new module for exploiting versions the software. Mailing software we must running next command is called valid ktsuss valid tokens with root privileges present. Module is root require default case with success such as The second Privilege Escalation stops ktsuss, also known as keep to improve the ktsuss current underscore 2019 underscore 1663 underscore Cisco underscore RMI underscore RCE.
And then we have a cool new feature now where you can type the old module name in and get the new module. It has an alias support. So
We do have an alias support, which I think we touched on that last time, maybe.
Yes.
So, but yeah, so if you didn't hear about that, go watch the last one, last recording. We do have an alias support now that helps a lot. In fact, we'll touch on it in just a second here. Contributor Rage LTman updated 32-bit, 64-bit Linux reverse TCP stagers to, when possible, read the specific number of payload bytes off the wire instead of a larger than necessary default size. It sometimes leads to an indefinite hang in the intermediate stager. So appreciate that fix. And our own ACAMIC refactored and improved handling of deprecated modules and frameworks so that if you attempt to use a module that was already deprecated and deleted, you will get a warning and automatically take it to the newer module, which is super cool. Makes for a much better user experience. And last on our list here, contributor Delta Clock provided a targeted fix to ensure our Python formatted payloads work with both Python 2 and Python 3, like compatibility. And a bug fix. Our own Shelby Paste dropped in a correction to the newer 64-bit Linux bind TCP pingback payload, ensuring it includes the correct handler. Thank you, Shelby. All righty. And a bonus slide. We have a bonus slide this week. If you missed the news from the Metasploit Town Hall at DerbyCon last week, the GitHub pull request for the Metasploit BlueKeep module is up. It targets 64-bit Windows 7 and Server 2008 R2. Default behavior is to identify the target OS, and if it is, decide if it is likely vulnerable. Actual target selection is manual. This was a true community effort, many hours spread across many people around the world. We really appreciate everyone who pitched in to make this happen. Super cool. Our own Brent Cook did a nice write-up about things BlueKeep, which includes quite a bit of information on detection and mitigation for blue teams in addition to exploitation notes. You can read it alongside our Metasploit wrap-ups at blog.rapid7.com. And as always, a huge thanks to everyone who helps make Metasploit better through their contributions. Thank you very much. How about some demos?
Yes, please.
All right, Mr. Brendan.
So I'm demoing, there are two privilege escalations on pretty late or pretty recent versions of Windows 10. It's kind of a funny story how it came about. We had Tim Wright, who is one of our contributors and is super awesome, submitted one of them. And when I was going through it, it didn't work. So I started doing research on the wsreset.exe, which is a Windows Store executable that goes and clears caches. wsreset.exe has an auto elevate built into it. And when I went through and read it, it didn't seem to follow, Tim's exploit didn't seem to follow any of the documentation that I had read. And after a while, I figured out that wsreset.exe didn't have one problem in it, it had two. It has both a DLL hijacking vulnerability in it and a registry hijacking vulnerability against it. So Tim and I worked together, we split our two modules apart, and so I was going to demonstrate both of them. In this particular case, I've got a regular session on Windows 10, 17.13.4, which is 1803, so it's a fairly recent. And there's nothing up my sleeve. I can't run get system, so background. The first one we're going to demonstrate is the registry overwrite, because that's a very straightforward vulnerability. There's not much to set in this. I believe it was session 4. Maybe if I spelled session right. I will switch over. One catch with using these is that you get a giant wsreset.exe pop-up on the remote host. So be aware there are artifacts. It then goes away. We get our session. VMware Now system.
All right.
Cool.
Now, that's fairly straightforward. All we do is we upload an executable somewhere on the machine. We overwrite a low-privileged registry entry. And after elevation, wsreset.exe launches whatever is in that registry location. The other actually combines two interesting vulnerabilities to this. And one of them is that the wsreset.exe is vulnerable to a DLL hijacking. Whenever you launch it, it automatically looks in whatever folder it is in and launches propsys.dll. The fun thing about it is that auto elevate relies on several things to work. One of them is the binary must be signed. So wsreset.exe is signed, and it must be running from a trusted location. This means you can't simply dump that propsys.dll file into the folder that wsreset is in. But interestingly enough, the verification process for a trusted folder isn't watertight. And so one of the things that this exploit, or this module does, is it creates a C Windows space system32 folder, which passes those checks. So notice here it's creating that directory C Windows space. It then copies wsreset to the Windows space system32 folder, and then uploads our payload as propsys.dll, and then we get our callback. And we're system again. The catch with this one is that that window stays open. So be careful using this particular one. And the other thing is, notice when we do, we have two Windows folders now. Okay. Any questions on that?
That's pretty neat. Do you think that the extra space in a phantom Windows folder could be used for DLL bypasses and a lot of other software as well? Do you have any kind of ideas for techniques for identifying what software might be vulnerable to that kind of attempt?
Yes, this is actually, there are a couple of write-ups on using this technique to bypass various forms of this DLL hijacking to avoid, to get through that trusted auto elevate feature. The biggest problem is there is almost no way that I have found to delete that Windows space folder.
Interesting. So you'd have to use like the API or some sort of like a symlink or some other kind of way to reference that folder.
Right. And notice it shows up as being the exact same as the original. So there is something going on in the background that is making the Windows file system very unhappy when you use this technique.
Yeah, it's even got the same creation date or modification date. That's amazing.
And size and yeah.
So when this vulnerability was fixed, was it just simply fixed in the was it fixed in the file system, or was it fixed in the
So that's an awesome question, because from the best I can tell, this was not Microsoft's response team did not say this was a bug. There is no CVE to this. This isn't a vulnerability. Instead, they released a excuse me for a moment. I have a meeting. They released a signature for it for Windows Defender. They didn't patch it. But apparently it doesn't work in later versions of Windows. But these versions, 1803 and 1809, are supposed to be vulnerable to both of these. And in theory, they're not being patched.
Okay. Oh, fascinating. Thank you.
No worries.
Thanks, Brendan.
Yeah, thanks, Brendan. Super cool. All right. Let's see. Let me see if I can usurp it real quick just to give the slide to. All right. Here's the demo everybody's been waiting for.
Okay.
I think. Maybe. You're going to get it whether you're waiting for it or not. BlueKeep with Brent.
Hopefully I didn't make you wait too long.
There you go. Thank you, Brent.
All right. So thanks for everybody. So I'm going to be demonstrating the exploit module that we have in the pull request queue right now for CVE 2019-0708, also known as BlueKeep. This is a module that, as we mentioned earlier, is a community effort. Zero Sum gave us kind of the initial, shared with us initial POC, which is actually pretty nifty. It used the Python external module support to integrate with Metasploit kind of directly with some external libraries. One thing to kind of note about this Metasploit module here is that it's one of our first modules that can actually build kernel level shellcode on the fly. It's kind of a little neat feature that we added to make other kinds of kernel exploitation simpler in the future. But I'll walk you through that a little bit. But first of all, let's talk a little bit about the vulnerability. Now, the vulnerability, was basically publicized about 4 months ago or so. There was basically a use after free in the RDP services of many different versions of Windows, where basically an internal channel, a channel being a way that different kinds of data is passed between the client and the RDP server. So for instance, audio, graphics, your clipboard, all those kinds of things are different channels. So there was an internal channel that accidentally allowed external users to use it, external clients to use it. And when you disconnect it from this channel, if you send a malformed disconnect message, it would basically cause a use after free vulnerability. So effectively, you as an attacker could sort of change what data would be pointed to at some point within the disconnect process. So that basically means the vulnerability is triggered on disconnect. If you can get shellcode sprayed into a sort of predictable location within the operating system, then you can basically leverage this use after free vulnerability to get indirect calls through a specific gadget within the disconnect code and execute code arbitrarily. Now, one of the tricks to this vulnerability have been for a long time figuring out how do I get the code in place to actually run? How do I predict where it needs to be, and how do I sort of get that uploaded? Because there's nothing directly that lets you do that. The way that this module works is it actually attempts to sort of spray the non-page pool with basically, and again, a non-page pool is a section of memory within Windows that basically doesn't get swapped to disk. So it's at a predictable location, it never goes away, so which is what you want for shellcode. One of the tricks is that the location of the non-page pool on newer versions of Windows is randomly allocated, so it's all over the place. And that's a security measure. Older versions of Windows, like Windows 7, Windows 2008 R2, they actually have it in a fixed location from reboot to reboot, but it's at a different offset depending on other characteristics of the host operating environment. For instance, if it's running in a virtualization and it's in a container, what kind of hardware it is, that sort of thing, how much memory you have, can even change where the non-page pool is. So there's a lot of different variables that at least this module today isn't able to determine on the fly. I'll show you a little bit about how the usage of the module works and kind of some tricks to being successful with the module today. Let's go ahead and take a look. So this is the information screen for the module. There's not a whole lot that you have to set. You can basically set the target IP address. If we do show options, we can see that you can, of course, just set a normal payload. The module today supports a number of targets. Let's show targets. And you'll see a little bit more of what I mean as far as like how specific the targets actually are. With the initial module pull request, we have basically 4 different targets. One that targets generic hardware, 3 targets for different virtualized environments as well. Although we found that also, for instance, VMware 15 and VMware 14 have different non-page pool offsets. So there have been some community contributions for different kinds of operating environments. We also had someone who verified that this exploit works in AWS, which is, again, a different kind of hypervisor based on Zen. And that, of course, requires different offsets as well. If we run the check command with the module, you'll see here that it actually leverages the existing BlueKeep check auxiliary scanner module under the covers. In fact, the way it's sort of indicating that right now, it's not intentional, but that's how it's doing it, is adding an extra space to saying I shelled out to a different module to do the check. with the pull request, we added some kind of neat things in that Metasploit can actually check to see what version of the kernel is installed, but it can't tell, for instance, if you're running Windows Server or you're running Windows 7. The reason why this is important is the groom channel. If we were to type edit on the module, you actually see here a few of the notes that are built into our documentation to kind of tell you things to watch out for. If you look at the top here, it notes that the way that we actually inject the shellcode is over the sound channel, the RDP sound channel. Now, this sound channel is actually disabled on Windows Server 2008. So you have to actually undisable the sound channel currently to get the groom code in. Now, there are some techniques that have been published for other ways to getting data into the kernel, and we may explore these kind of in the future. But for right now, this is kind of a list of to-dos to implement within the module. So again, what I showed you here is the check option works. Let's go ahead and run the module and sort of give you an idea of what it does by default. Because the user is required to target the module more specifically, the module actually will bail out, we'll do a check, and we'll say that it aborted due to a non-existing configuration. You basically need to set the right target manually. So let's go ahead and do that. Because my targets are running on VirtualBox, I'm going to say set target to, which is the VirtualBox channel, or VirtualBox target, and let's go ahead and run it. What this space is going to do is it's going to actually target each of the target operating systems one by one. I use the Metasploit 5 rhosts command to make sure that it targets everything as sort of a batch. What it's done first is it checked to see if all the channels that we need to exploit are available. And the second thing it did was it actually injected all the shellcode. And then finally it did the disconnect, which did the use after free, which then jumps into the shellcode and then loads interpreter. There's a lot of documentation inside the module exactly how that works, but it's basically exactly the same as Admin 17010's kernel shellcode, the user space jump that was originally pioneered by Sleepia as part of his Eternal Blue module. So you see here that we actually ran this module against two different target OSs. If I type sessions, you can see verify that I now have two sessions against two different hosts. If I go ahead and run sessions, I believe -C sysinfo, I can actually run sysinfo against each one of them and show that I have a Windows 7 Service Pack 1 shell and I have a Windows Server R2 shell. Go ahead and do a get UID. I can verify that we're all running a system already. No privilege escalation needed because we went from kernel straight into the privilege escalation, into the user space. One other thing to note is that because this needs to basically be a sub-process of an existing process within user space, we actually currently hang it off the print spooler, which is the same as M17010. This could be modified, but that's a pretty reliable target. If it crashes, it always comes back. That's one reason why a lot of times people prefer it. If you're looking for IOCs, that's something to look for, is basically processes hanging off the print spooler are definitely something that should be viewed as suspicious. Now, that doesn't necessarily mean that's the only way that this module could work in the future. And so obviously detecting the techniques and of course patching your servers is obviously the best solution in these particular cases. So that's it. Any questions on the BlueKeep module for right now?
Excellent.